And as you probably remember, we were writing our own kind of crappy version of a vector, right? And we made an array, and the array was kind of bigger than the size of the data inside of it. When the array got full, we made a bigger array and copied things over. And so we did all these different operations. We did adding, and we did inserting. Adding is pretty easy. We did inserting in the middle, where you have to shift things over. Like to make room for this 42, you have to do a loop and shift things over. We did that. We did some other methods. We did some removal code where you have to shift things to the left. So that's kind of where we are today. I want to talk about a few new features that that class should have before we move on. One of them is called a destructor. Some people call it a deconstructor. That's wrong. It's a destructor. So a destructor is kind of the opposite of a constructor. Constructor is what runs when a new object gets created. Like when the main method or somebody creates a ArrayList object or a date object or a vector object or whatever, that is a constructor getting called. When an object is disposed of and thrown away, that is when a destructor gets called. And this is something that happens automatically in terms of the destructor being called. It happens automatically whenever the program is done with that object. But you can write some code that will execute at that moment. And the syntax for a destructor is the same as a constructor, but you have a tilde at the start of it, a squiggle character. So let me see if I can show you kind of what happens here. When is a destructor called, and why would I want this thing? Well, if we go back to the program that we wrote, here we have ArrayList.cpp, and we also have ArrayList.h as well. Now, if you look at the code for ArrayList.h, they have a constructor here. I'm going to add a destructor. And that's just tilde ArrayList, okay? And if I go to ArrayList.cpp, here's the code for the constructor. The code for the destructor looks the same, except the name of it is tilde ArrayList. And so again, this is when an ArrayList is destroyed, you might say. So what should I do here? Well, let me, just for the moment, let me just do cout destructor called. Okay? See, now, when I hear the word destructor, like, I'm pretty sure when I was a kid there was a Transformer toy called Destructor. And so I think of Transformers, and I want to go play with Optimus Prime and stuff. And I guess you guys probably don't remember when Transformers didn't suck. Michael Bay sort of ruined him in Ninja Turtles. Basically, everything I love, he's ruining, you know, him and George Lucas, basically. OK, so destructor gets called when an ArrayList is destroyed. But when does an ArrayList get destroyed? Well, ArrayLists are being created and destroyed when code uses them and when it's done using them. Here's a piece of code that creates an ArrayList. When does that ArrayList get destroyed? Well, when it falls out of scope. When it hits the end of main, it goes away. OK? So if I run this program, I should see that destroyed message once, because this is the only list that the main program creates. So it says destructor call. OK, fine, whatever. But what if I have a method here like test add? Well, maybe in here I say ArrayList list2. And now that list is going to live until the end of this test add method. So if I run the code again, we're going to see destructor called twice. And I believe the first time it's called is the one that's being called by test add, because test add is done running before main is done running. So I mean, it doesn't really matter the order, but they're both being cleaned up. Whenever the variable falls out of scope is when that destructor gets called. OK, but what I really want to talk about is, you wouldn't really put a cout statement in here. What would you actually do in here? Well, remember what I said. When you allocate the memory for an array, you say new int, I want an array of 10 ints. I talked about this kind of near the start of last lecture. I said that when you create an array, when you're done using the array, you have to delete the array. Remember that? And why you have to do that is because C++ doesn't automatically manage the memory for you. If you don't take care of cleaning up the memory will leak. OK, well, this program here has a memory leak in it. And the memory leak is when we create an array list, we create an array of 10 things, and we never free up that array ever again. There is a place where we delete something. At the very end of class last time, whoops, where did it go? At the end of class last time, we wrote this thing called check resize, which would make the array bigger if necessary. If I'm out of space, make a new array that's twice as large, copy things over, delete the old array, switch to the new array. So here I'm doing delete. But I'm only deleting the smaller one, then I keep the bigger one. Now the bigger one's going to leak. Eventually, whatever array the list is using for its elements is not going to get cleaned up when the array list falls out of scope. That's a memory leak. And if you want me to, can I demonstrate this? Let me think. I didn't actually prepare this. I think I have like a test leak method. Now, I don't remember what this does. What does it do? It, a million times or some number of times, creates a list, and that's it. Doesn't do anything with it. And then here it says, get line, done memory leaking, press enter. I think the reason it does that is so that the program will pause there so that I can see how much memory the program is using. Okay? So let's find out. I'll build it and I'll run it. And I'm going to load up a terminal. Or maybe my computer is running really slowly. Oh, man. Why did I turn the value so high? I always have to go for the big demo. Why couldn't I just show it to you with 1,000 array lists? No, I had to go to 1 billion array lists. Oh, man. OK, wait. This is too much. I can't take it. OK, I'm going to stop it. OK. Now the terminal shows up. Thanks. OK, wait. Let's turn it down a little bit. OK, let's just try this. Let's just do 100 lists. That's not very many. And I run this thing, and it should just sit here. It says done leaking, press enter. OK, now if I go over to my terminal and I say top, let's see, how do you view memory usage? You would think that I would prepare this before class. How do I sort by the memory? Hey, section leader, TA people who are here. Figure out, how do I do the memory usage of a particular program? I know how to do it on Windows, but I'm too cool to use Windows. Isn't it top something? Man top. Oh man, I'm not reading manual pages in front of hundreds of people.
You can try just like ps augs grep it, and then it may show up enough information.
You're crazy. I'm not listening to you anymore. 2C, memory usage. OK, how about PSEF grep Java? Grep, what's it called? ArrayList? This is like a riveting lecture. I bet SCPD people are going to watch this twice. You're like, wow. It's like a Game of Thrones season finale, and you're like, wow, let's watch it again. Yeah, OK, I can't get the memory here. OK, well, whatever. Whatever. I guess I can't show it to you. Sorry, I had this demo working on my other laptop. How do I do top? So how do I sort by the memory? M. Well, that does seem to list things. Wow, Dropbox is using 2 gigs of my memory? Fuck you, Dropbox. Well, at least something is being learned. We're learning that Dropbox hogs memory. That's it. You're dead, Dropbox. 6761. Kill. 67. How do you like that, Dropbox? Where are you now? Yeah, nowhere. That's where. OK, well, let's try this again. So let me run this program where I'm leaking lots and lots of array lists here. Turn out that's maybe a little better. Maybe one more. OK. So I'm trying to make it so, OK, can I see this thing? OK. No. No. Ugh. OK, it's too fast. Hang on, you got to give me one more chance. It's going. Java. It's using memory. Where is it? Ugh. Wait, is Dropbox back? I saw Dropbox again. OK, fuck it. Forget it. OK, just pretend. Pretend that I could show you how much memory a program was using. Every single time I create this list, and then I immediately delete it, and I wrap back around, and I do this loop again. Wow, my computer's all over the place. Look at this. I'm like jiggling the windows. It's just one of those days. Every single time this loop wraps around, it creates a list, and then that list creates an array of 10 elements, and then the array of 10 elements is just sort of lost. That memory gets claimed by that list, and nobody unclaims it. So over time, this program will run out of memory. It'll use up all the memory on my whole computer. Remember the first time I ran it where I had too many digits, too many zeros there, and my computer started getting all effed up, and it wouldn't run the terminal, and I couldn't do anything? Basically, this program was like eating all the memory in my computer. And if you think about it for a second, it probably shouldn't do that because I'm just creating a list, throwing it away, creating a list, throwing it away. Shouldn't the memory usage go from like 0 to a little bit to 0 to a little bit? Shouldn't it just like not use all my memory? But it did, you know? That's a memory leak. So what you usually do in a destructor, remember that's the whole point here, destructor is you usually free up any memory that you need to free up that came from your class. So in this case, you would say delete array my elements. Okay? That's all you need to do. Now, some students asked me after class last time, like, well, do I have to delete my size? I'm like, what about there's other things that are in there? Do I have to delete other things? And what I would say is no. C++ manages some memory for you. We'll get into it more later, but the one piece of memory it doesn't manage for you is if you ever say new. If you say I want a new array of ints, then that basically is you saying, I want control of this. I want to manage it myself, and when I'm done with it, I will delete it. Therefore, I have to say delete on that. I didn't say new on these things, so I don't have to say delete on them. That's a good rule of thumb. Everything you do new on, you have to do a delete on later. Okay? So that's a destructor.
What is the advantage of new?
Why do I say new? Well, I mean, I guess if I'm being really practical about it, that's kind of the required syntax to create an array. So you have to do this when you're dealing with an array in this context. So you're asking what's the benefit, what's the advantage? I mean, I don't really have another choice that'll work here. You don't have to say new to use an array, but if you don't, then you won't be able to grow it larger later. If you don't say new, you get locked into the size and you can't resize it. It's kind of a complicated thing, but there's no real other way to get the behavior that I want here. So in order to get this resizable array thing that I'm doing here, I have to have this dynamically allocated memory that I have to manage myself. It's just a C++ thing. If we were teaching the class in Java or Python, I wouldn't have to say delete. It's just a C++ thing. And it's also true in other languages like C and assembly language, lower level languages that make you manage things more manually than Java or Python or languages like that. OK, so that's mostly what I want to say about arrays and ArrayList. We did most of the code to write the ArrayList together already.